Hello, everybody. This is Gigi from Kauai Community College. In this video, we will be talking about some basic integration that are not too basic. They have some tricks to it, so let's take a look. Suppose for the first one, we have the integral of sine x plus 1 all divided by cosine x dx. Okay, now from earlier, we know that we should rewrite this as two integrals, right? Split them into multiple fractions. So this would be sine x over cosine x dx plus an integral of 1 over cosine x dx. Now, the question here we want to say is, well, do we want to write sine x over x as tangent x? And so if we did that, it will look like this, right? Tangent x dx. Well, no, that's not going to be helpful because that's not the derivative of something that I know. However, if I let u be cosine x, then du will have a sine x dx. So that is perfect right now for u substitution. Okay, now the second integral, 1 over cosine x. Well, if you were trying to do u substitution, then again, if u is cosine x, then du would have to have sine x in there. So that's not very helpful. In which case, for this one right here, we actually would want to write it as 1 over cosine x is secant of x. Okay, so one we want to rewrite the trig function, the other one we don't. Okay, now for this first integral, the integral of sine x over cosine x, I would say let u be cosine x. So then du would be negative sine x dx, right? So then that integral will just become the integral of negative 1 over u du, which will equal to the negative ln of absolute value of u plus c. Okay, so that's the first integral. Now that is that. Now this one then will equal to negative ln of absolute value of cosine x. Okay, I'm going to go ahead and leave the c there for just a second until I find out what the answer is for the second integral. Okay, now for the second integral, what I'm going to go ahead and rewrite that. That's the integral of secant x dx, right? It will be then, there's a trick to this, which is like, well, if you haven't seen it before, how would you know, right? Well, here's the thing. I don't know any derivative that just has secant x, but I know a derivative that has secant tangent, right? So I wish to have secant tangent. So what am I going to do? What's the trick? I need a tangent in there, right? But I can't just multiply both by tangent, can I? Well, if I multiply the denominator and numerator by tangent, then if I let u be tangent x, like how we did earlier with the cosine, then du gonna be, oh, the derivative of tangent is secant square x. Oh, oopsie, I don't have secant square x. I actually have secant tangent. So what am I going to do? Here's the trick. You are going to multiply by 1, but your 1 is going to be secant x plus tangent x, and you'll see why that is. Okay, so give me a second here. You'll see why that is. I'm going to give myself some room so we can go ahead and do that integration. All right, so here when you multiply by secant tangent, what you have on the numerator, and don't forget the dx is over there. Okay, the dx is over there already. So here you have secant square x plus secant x tangent x. Those are both some derivative that I would recognize, right? And the denominator, you have secant x plus tangent x, but I'm going to rewrite that as tangent x plus secant x. Do you see how now the denominator have their matching derivative on the numerator there? So I can do a u substitution, right? So if I let u be tangent x plus secant x, then my du would be secant square x plus secant x tangent x dx. And that would be this part right here, right? So that integral will just be integral of 1 over u du, which give you ln of absolute value of u plus c. And this is c2, and let's say that's c1, right? Anyhow, the derivative, the antiderivative of secant x now becomes just ln of u, where u is tangent plus secant. So this now becomes ln of absolute value of tangent x plus secant x plus some constant c. And that is why I call this a tricky integration. It requires a trick that you probably haven't seen before, and you probably but have a hard time thinking of it on your own if you didn't see that before. All right, so that is that.